Welcome to section 3.7, the angle side theorems. Our objective is to apply theorems relating the angle measures and side lengths of triangles. For homework, we're going to have in section 3.7, page 152 to 155, 2 to 12 the evens, 13, 16, 21, and 22. Okay, so we have our first theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So here's what I know. I know that side AB is going to be congruent to side BC. Let's put in those markings. AB, BC. Now the angle opposite or not attached to BC is going to be angle A. And the angle opposite side AB is going to be angle C. So if we know the two sides are congruent, then we know those angles opposite, A and C, are going to be congruent. Now, a shorthand way of writing this theorem is going to be if sides, then angles. And that's going to be our shorthand for this theorem right here. If we know the sides are congruent, then we know the angles are congruent. So now we have the converse of that theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here's what we know. We know angle D is congruent to angle E. Now, the side opposite angle D is going to be side CE. The side opposite angle E is going to be side CD. So if angle D is congruent to angle E, then segment CD is going to be congruent to segment CE. Now, just like on that last theorem, we have a shorthand for this. We start off knowing the angles are congruent. So if angles, then sides. So the converse of what we had. Okay, so we have two ways to prove that a triangle is isosceles. The first way is at least two sides of the triangle are congruent, the triangle is isosceles. The second way is if we know two of the angles of the triangle are congruent, the triangle is also isosceles. So we can prove a triangle is isosceles either with its sides or with its angles. Alright, so let's do some pretty scary examples. Okay, so for our first one we have a proof. Let's copy down that picture and let's get our proof going. So here we go. We got statements and our reasons. So we're given that angle E is congruent to angle H. We're also given that EF is congruent to GH. Both of those reasons given, and I'm going to mark them in. Angle E is congruent to angle H, and EF is congruent to GH. Now, I see that I have on one single triangle two angles that are congruent. Now, if two angles of any single triangle are congruent, those sides opposite are also going to be congruent. So for my next step, I'm going to say that DE is congruent to DH. My reason? If angles, then sides. Now I look at my triangle and I see that I have side angle side. Triangle DEF is congruent to triangle DHG, side angle side. Now, if these two triangles are congruent, we know their corresponding pieces are also congruent. DF is a full side of one triangle, and DG is a full side of the other triangle. So I'm going to say DF is congruent to DG, CPCTC. Alright, so here's our next one. Again, let's copy down the picture, and let's put our givens into our statement and reasons. So here we go. We got our statement, and we got our reasons. So, we have triangle JOM is isosceles with angle JOM, the vertex, angle, and OK bisects angle JOM. Those are all given. Now, first thing that I see between these two triangles is I definitely see that I have a reflexive side. I'm going to say that OK is congruent to OK, reflexive. And put in my tick marks. Next, I'm going to go off of my first keyword, isosceles. By definition, isosceles means congruent sides. So if JOM is going to be my vertex angles, those sides that are congruent, those legs, are going to be sides JO and side OM. The reason? Definition of isosceles. I'm going to put those markings in. My next keyword is bisect. Now, what's being bisected is this angle JOM, making two congruent angles. I'm going to say angle JOK is congruent to angle MOK. Definition of a bisector. Okay. Looking at my two triangles, I see they're going to be congruent by, again, side angle side. Triangle JOK is congruent to triangle MOK, SAS. Two sides and an included angle. Now, let's kind of go back and touch base with our conclusion. We're trying to prove that OK is the median to the base. What would we need to say it's the median? Well, in order to say it's a median, we have to know that's being bisected. Now, it is being bisected. We know that because of CPCTC. We know that side JK, a full side of my left triangle, is congruent to KM, a full side of my right triangle. That's my CPCTC step. Tossing in those markings. And now I see that I have a median. A median, by its definition, means that it's going to start from a vertex and cut a side opposite the vertex in half. I definitely have that. I got that segment. The segment starts from my vertex. It's chopping that other side in half. So let's go ahead and draw our conclusion. OK is the median to the base. Now, we got to be careful with my wording here. So here we go. For my wording, if a segment from a vertex divides the side opposite into two congruent pieces, it's a median. So again, the wording on that's a little awkward. We have to have what makes the median. A, it starts from a vertex. B, it divides the side opposite into two congruent pieces. So it's really important that we convey all that information and what our reason's going to be. Alright, so the moment you've all been waiting for. Our last and final proof. Copy down the picture, press pause, try and get your way all the way through this proof. If you need a little bit of help, unpause it, listen to what we got, and try and work your way through. Alright, so here we go. I got those givens and I got my markings down. So the first thing that I see is I got two sides of these little triangles right here. And I also have these outside angles. Now, I'm not given any useless information, so I definitely want to talk about supplementaries in here. So here we go. I got angle 3 is going to be supplementary to angle WBX. If two angles form a straight angle, they are supplementary. Okay, my next pair right over here. Angle 4 is supplementary to angle ZAY. Let's say same as 4. Now, we got our nice cross-offs right here. Angle 3 crosses off, angle 4 crosses off for repeats. What I'm left with is angle WBX is congruent to angle ZAY. The reason? If two angles are supplementary to congruent angles, they are congruent. Or for shorthand, supplements of congruent angles are congruent. Alright, I'm going to put those markings in here. I got my nice Chicago Bears color. Go Bears. And here we go. Let's look at those triangles. I see my triangles. Triangle WBX is going to be congruent to triangle ZAY. For my reason, side angle side. Now, If I'm trying to prove that it's isosceles, I either need to have congruent sides or congruent angles. CPCTC tells me that I have congruent angles. I'm going to say angle W is congruent to angle Z, CPCTC. So if these angles right here are congruent, that's enough information to tell me that this big, huge triangle is congruent. That single triangle has congruent angles. So I'm going to say triangle WTZ is isosceles. The reason is if a triangle has two congruent angles, it's isosceles. Beautiful. Okay, last but not least, we have our homework answers. Alright, here's the answers we got to that homework. Pay particular attention to number 22. For number 22, I got 9 steps for that one, and I double-checked it. It's definitely 9 steps. But you have to use 2 pairs of congruent triangles. So you're going to prove one set of triangles are congruent. You're going to do some CPCTCs, some additional steps. Prove another set of triangles are congruent. Some CPCTCs, and some other step. So number 22 is going to be tricky. I know you can do it, but just keep in mind that it's going to be a little bit tricky. Have a good one.